Alright, so in this video, we're going to understand the logic behind matrix multiplication, right? So let's say we have been given two matrices, A and B. Then we know that if the order of A is, say, M cross P, then order of B has to be P cross something, say N, right? So we know that if this is P, then this has to be the same, P. But why is that so? Why should the number of columns in the first matrix be equal to the number of rows in the second matrix, right? So yeah, let's try to understand this. Now, what is actually what are matrices used for? They're used for solving equations, right? And by solving equations, we mean that we give certain input and there is a certain process and then we get an output, right? Now, if this process is blank, then our input, say, let's say Q is our input, and if this process is blank, then our output would also be Q. Or if not blank, it can be an identity operation which gives itself as an output, right? But we are not discussing this case, right? We will be discussing that when there is a certain process that gives a separate output, distinct output, right? So let's take an example of a matrix A with the order 2 cross 3 and B with the order, say, 3 cross 4, right? So let's form this. Take it as A1, A2, A3, B1, B2, B3. Okay, and this is my matrix A, and B. Let's take C1, C2, C3, C4, D1, so on, and E1 till E4, right? This is our B. Okay, now I talked about inputs and outputs, right? So in this case, what is happening is, okay, in this case, in this particular case, how many inputs do I have? This represents my inputs. So I have, let's say I have Q and R as my inputs. Okay, so now this whole thing, this represents my process. Okay, now Q and R are my inputs, and what the first matrix is doing is that it is applying certain conditions which are a part of the process. So as I can see, I have three conditions, say S, T, and U. Okay, so my input Q and R is giving me these three conditions, S, T, and U. And then, not giving me actually, they are going through these three conditions for an output. Okay, so now what I need is that for the second matrix, I need a point where S can land, where T can land, and where U can land. Okay, I can't leave any of these conditions. I need to have all three of them. And this is the reason why I have S, T, and U here. Because the first matrix gave me three conditions, and for an output, I need to deal with all the three conditions. I cannot skip any condition, right? And now these three conditions, I can see that they are giving me further four different outputs, right? And say I'll call it V, W, X, and Y. Okay, so these are my inputs and these are my outputs, and they will form a matrix of 2 cross 4, which is pretty obvious, 2 cross 4. So my output matrix AB will be a 2 cross 4 matrix. I'll call it C. Let let AB be the C or O output matrix. Ah, looks like a zero. Let's keep it C. Okay. So this is the logic actually. My inputs, again, my inputs have to go through certain conditions. And in the second matrix, when I'm operating, then I need to have an entry point for all three conditions. I cannot skip any condition for an output. I need to consider all the three conditions, or four, or p conditions. Whatever the number is, I need to consider all those conditions, right? So this is why this p and this p have to be same. Yeah, well, if you have any doubts, then feel free to comment. I'll be happy to resolve them.